Okay, here we have the methods in learning from Coursework 6.1.2. Albert Einstein is famous for his theory of relativity equation, E equals mc squared, wherein E is energy, m is mass, and c is the speed of light. I don't know why you use c. So the equation could be stated as energy, E, is equal to mass times the speed of light squared. So that's exactly how you'd read that. But what if you wanted to know this in terms of mass? You would have to isolate m instead of E as follows. So we start again with E equals mc squared, but we divide by c squared on both sides to get the m alone. So E divided by c squared is equal to m. In other words, we divided both sides by c squared, getting the m alone. So E divided by c squared equals m, or m equals E divided by c squared. Or, in words, mass is equal to energy divided by the speed of light squared, which is equally true and no less confusing. Alright, but all we're really doing there is isolating the m. So it's the same thing as going from standard form to slope-intercept form. We're getting a variable alone. It's actually one operation. Very simple. So what about another famous equation, the Pythagorean Theorem? You know, a squared plus b squared is equal to c squared. This is for right triangles in geometry, wherein a is the short leg, b is the medium leg, and c is the hypotenuse of a triangle. The Pythagorean theorem could be stated as the short leg, a squared, squared, plus the medium leg squared, that would be b squared, is equal to the long leg squared. But what if we wanted to know this in terms of the short leg squared? You would have to, or in fact, I think it says the short leg. You would have to isolate a instead of c squared. So what we'll do here is we're going to try to get a alone. If we're trying to get a alone, the first thing we're going to do is subtract b squared. The easiest way to get that is to just copy and paste it. We're subtracting b squared from both sides, leaving, we subtracted b squared from both sides, so that's gone. And then we have c squared minus b squared. So c squared minus b squared, because we subtracted b squared from both sides. Now we need to take the square root of both sides to get the a completely alone. So what we'll do is we'll use this symbol. And again, it's a nice copy and paste job for now. The square root of a is equal to, the square root of a squared, my bad. The square root of a is squared, because what we're doing is we're taking the square root of both sides. So we're taking the square root of that is equal to the square root of c squared minus b squared. All right, and then that puts the final thing. Now, the square root of a squared, what that equals, because it's the square root of a square, what that equals is just a. So a is equal to the square root of c squared minus b squared. Or in other words, a is the short side. So the short leg is equal to the square root of, we'll look at c. C is the hypotenuse, so it's the hypotenuse squared minus the, this is b, so that would be the long leg squared. And that would be our quote for how to find a in the Pythagorean theorem. And it looks like I misspelled equal. My bad. And I still misspelled equal. But now it's right. Okay. So the short leg is equal to the square root of the hypotenuse squared minus the long leg squared.